prove that the sum of n terms in an arithmetic series is n by 2 bracket twice a plus n minus 1 into d. Solution. The solution is this. Let a be the first term, a is the first term, d the common difference, d is the common difference, n the number of terms, and L the last or nth term in the arithmetic progression. A is the first term, D is the common difference, N is the number of terms, and L is the last term. Let Sn be the sum. We can write, so can you write Sn equal first term A, second term A plus D, third term A plus 2D plus, there are so many terms like this, first term, second term, third term, and then third last term plus second last term plus L equals to number 1. L I said first term A, second term A plus D, third term A plus D, 2D, and so many, and third last term L minus 2D, second last term L minus D, and last term is L. You can write in this way. It can also be written in the reverse order. यसलाई रिभर्स अर्डरमा पनि लेख्न मिल्छ. फर इक्जाम्पल Sn equal first term then last term just below it. First term भन्दा मुनि यो last term यता लेख्ने. Last term plus second last term L minus D, third last term L minus 2D plus dot dot, and this one third last term A plus 2D, second last term A plus D, last term below first term. फर्स्ट को मुनि लास्ट लेख्ने, लास्ट को तर फर्स्ट टर्म लेख्ने. फर्स्ट टर्म लास्ट टर्म, second term second last, third term third last. Here in this way, see, third term here, third last term third term, second last term second term, last term first term, adding 1 and 2. When you add the first and second equations, Sn plus Sn twice Sn, A plus L, write A plus L plus A plus L plus dot dot 2 n terms. There are so many A plus L terms. A plus L say n वटा छ, or twice Sn equal, there are A plus L, A plus L, A plus L n times. So n times A plus L. You can write n times A plus L, or twice Sn equal n A. L is the last term, therefore L can be written as A plus n minus 1 into D, because Tn L equal A plus n minus 1 into D. You can prove it. The last term is written as A plus n minus 1 into D. A is the first term, L is the last term, D is the common difference, N is the number of terms, Sn is the sum. Sn is first term, second term, third term, dot dot, second last term, third last term, second last term, and last term. It can also be written in the reverse order. Sn equal last term plus second last term, third last term plus dot dot, third term plus second term plus first term, add, by adding we get Sn plus Sn, twice Sn, A plus L, dd cancel, A plus L, A plus L, A plus L. In all times, there are n times A plus L. यस्तो A plus L n वटा हुन्छ. So write n into A plus L. N, A is A. L is last term. So A plus n minus 1 into D. This is the last term. So A plus A twice it. You can easily prove it. Or this 2 is written n by 2. A plus A twice A plus n minus 1 into D. Right, a little bit down. Or twice Sn equal n by 2. A plus A twice A plus n minus 1 into D. Twice Sn, 2 times. Therefore, Sn is n by 2 twice A plus n minus 1 into D. Proved. What is the sum? You can write Sn equal in the increasing order A plus D, A plus 2D, लेख्ने, and write in the reverse order, decreasing order. Suppose A plus D, A plus 2D are decreasing. So write in the first increasing order equation 1, decreasing order equation 2, add the equations twice Sn equal A plus L, A plus L, A plus L, n times. Twice Sn equal n times A plus L. N, A, L equal A plus n minus 1 into D, because L is the last term. A plus A twice A, divide by 2. Therefore, sum Sn equal n by 2 times twice A plus n minus 1 into D. Proved. In this way, you can easily prove. Now, geometrical mean. Now, prove that the sum of n terms in a geometric series GP is Sn A r to the power n minus 1 by r minus 1 also equal to Lr minus A by r minus 1. How to prove that the sum of the geometrical series in, there are n terms in geometrical series, the sum of all terms is Sn equal A times A r to the power n minus 1 upon r minus 1 or Lr minus A by r minus 1. Solution. Let A be the first term, R the common ratio. In AP, D common difference, but here common ratio. A is the first term, R is the common ratio, N the number of terms. There are n number of terms. L the last or nth term, and Sn the sum of n terms. There are n terms. Therefore, sum of n terms is Sn. A first term, R common ratio, A last term, n number of terms, and Sn sum of all terms. can you write, we can write Sn as first term. A is the first term, so write A. Just like in AP, A plus D, A plus 2D, dot dot dot. A plus D, A plus 2D, dot dot. In the same way, in GP, A plus AR plus AR square plus dot 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 plus AR to the power n minus 1. Equation number 1, sum of all term, first term plus second term multiplied by R, third, fourth, fifth, dot dot, second last term. So you can write not only this, not only A plus, I write one more, third last term also, right? AR n minus 3 plus AR n minus 2 plus AR n minus 1. First term, second term, third term. See, last term AR n minus 1, second last term, third last term. Multiplying by R. Multiplying equation 1 by R, the common ratio, we get RSN. SN R times S. A, don't write A. यसको मुनि चाहिँ यसलाई चाहिँ यो R ले यसलाई मल्टिप्लाई गर्दा यसलाई मल्टिप्लाई गर्दा AR हुन्छ. You write AR plus R into AR square, AR cube plus AR, see, AR square, AR cube plus dot dot dot. This can be written as plus AR n minus 2 minus 3 becomes, see, R ले multiply गर्दा एउटा power बढ्छ, AR to the power AR n minus 1 and AR n. Question number 2. Adding, or sorry, subtracting, यो R ले multiply गर्दा के हुन्छ, A like A into R, AR into R, AR square into R, AR cube. In the same way, you can multiply all the terms by R, common ratio. You will get the result. AR n minus 3 becomes AR n minus 2, AR n minus 1 becomes AR n minus 1, n minus 2 becomes n minus 1, AR n minus 1 becomes AR n. Subtracting equation 1, equation 2 from equation 1, we get Sn minus Rsn. See, the technique, in the AP you have to add the two equations. AP ma jodne. In geometric series or geometric progression, you have to subtract equation 2 from equation 1. Equation 1 is general, Sn equal AR square, sum of all. Equation 2 is multiplying by R. What we get? Rsn, AR square, AR cube, dot dot, AR n minus 1, AR n minus 1, AR n minus 2, AR n minus 1, AR n. By subtraction we get A. What we get by subtraction, I just show. Here, all the terms are cut. AR cut. For example, see, like this. So by subtraction, I show the equation Sn equal A plus AR square plus dot dot AR n minus 3 AR n minus 2 plus AR n minus 1. And Rsn equal, see, AR square, A becomes AR becomes AR square, AR cube plus dot dot AR n minus 2, AR n minus 1 plus AR n. Equation 2, equation 1. On subtraction, what will be the result? Minus A. this plus AR cancel, AR square cancel, AR cube also, all the terms are cancelled. But only the last term is left. You cancel, all the terms except the first and the last are left. So you can write on subtraction, you can write as Sn minus Rsn equal A minus Arn. The first term A is left and only the last term Arn, Ar to the power n is left. All other terms are cancelled. सबै टर्म काटिन्छ, फर्स्ट र लास्ट मात्रै बाँकी हुन्छ. or Sn common 1 minus R, Sn common 1 R, here A common 1 minus R to the power n, or Sn equal A 1 minus R to the power n upon 1 minus R. Take minus common. If R is less than 1, this formula is valid. If R is less than 1, Sn equal, take minus common, A R to the power n minus 1 by R minus 1 if R is more than 1. If R is more than 1, A R to the power n minus 1 upon R minus 1. Now, Sn can also be written as multiply A R n minus A by R minus 1. A R n can be written as A R n minus 1 into R minus A by R minus 1. You R n minus 1 R, you R cancel, 1 cancel, A R n. A R to the power n minus 1 is last term L R minus A by R minus 1. Because Tn or last term is A R n minus 1, already proved. You can prove it, the term. Therefore, we can easily prove that the sum of the terms is A times R to the power n minus 1 upon R minus 1, or Lr minus A upon R minus 1 proved. In this way, you can prove others as well. This was for today.